Good morning to one and all. This is Vasi Priya from Vasireddy Venkatadri Institute of Technology. Today in this lecture, let us see conversion of NFA to DFA. First, let us see what is this NFA. NFA means non-deterministic finite automata. This is easy to construct than that of DFA. Because NFA, we can identify a finite automata as NFA where there exist many paths for specific input from the current state to next state. Every NFA is not DFA, but each NFA can be translated into DFA. Here, M is equal to Q sigma delta Q naught and F. Q is a finite set of states. Sigma is the finite set of input alphabets. Q naught is the initial state. F is the final state. The transition is delta is the transition function. So this is all about finite atom no, and NFA. Non-deterministic finite automata. Now let us consider a simple example and convert it into DFA. Here, as you can see, I have taken a NFA. It consists of three states Q0, Q1, Q2. Q0 is the starting state and Q2 is the final state. Here, as you can see for Q0, we are having two transitions for specific input symbol 1. So from Q0, for same input symbol 1, we are going to Q1 as well as to Q2. So we can say this as a NFA. There exist two paths for input symbol 1. So let us see what is this given data for NFA. M is equal to Q sigma delta Q naught and F. Q is Q naught, Q1, Q2. Sigma is 0, comma 1. Q naught is the start symbol, that is nothing but from the transition diagram Q naught. F is the final state, that is equal to Q2, and delta is the transition function. Q cross sigma gives rise to 2 power Q. This is all about the given data of NFA. Now let us convert this diagram into some transition table. Here for Q naught, as it is a start symbol, it is represented as arrow mark, and Q2 is the final state, so it is represented with star. At 0, Q naught for 0, it goes to Q naught. So I have represented at 0 Q naught. Again for 1, it has two transitions Q1 and Q2. So I have represented at 1 Q1 and Q2. Same as it is for Q1, for 0 transition, it goes to 0 as well as to Q2. So I have represented here for Q1 comma Q2. And for 1, it goes to Q2. So I have represented for 1 Q2. In the same way for Q2, I have represented the transitions for 0 and 1. So while converting this NFA into DFA, for start symbol Q naught, I am considering this Q1 comma Q2 as one in state Q1 to Q1 Q2. So here I am having present two states. One is Q naught and Q1 Q2. In this both, the new state is Q1 Q2. Q naught already exists here. So Q1 Q2 is the new state. So I will need to find the transitions for Q1 Q2. So here I have represented Q1 Q2. I need to find the transitions Q1 Q2 for 0 and also for 1. First let us see Q1 Q2 transition for 0 input symbol. So it gives us to transition of Q1 comma 0 union transition of Q2 comma 0. For Q1 comma 0, we are having two states Q1 comma Q2 union. For Q2 comma 0, we are again having two states Q0 comma Q1. The combination of these three, that is the union of these two, gives rise to Q0, Q1, Q2. I am considering this as a new state together Q1, Q2, Q0, Q1, Q2 as a new state. I have represented this here. Again with the 1. Q1, Q2 with 1 gives rise to transition of Q1, comma 1 union transition of Q2, comma 1. Transition of Q1, comma 1 gives rise to Q2. Sorry. Gives rise to Q2 and gives rise to Q2 and transition of Q2 comma 1 gives rise to Q1. So the union of Q1 comma Q2 I am considering as a single state Q1 Q2. I have represented for transition Q1 Q2 to 1 gives rise to Q1 Q2. So I have completed the new transition state Q1, Q2. So for